All right, we'll start with the simple case, finding gravitational potential energy. So here's what we're going to imagine. We start out with an object, maybe something like a book, and over time we take it from this initial state to some final state that is at a different elevation. So we're going to start out with its location being initially relative to some reference point, y initial, and it's going to end up at some reference point y final. The gravitational force acts exclusively downward with a size mg, so if there's any motion sideways, motions to the side don't matter. The dot product will be 0 with those motions. So, cool stuff. All right. So in this case, since we have a motion along the positive j direction, but we have a force along the negative j direction, we could actually think about the work in its most simple form. We can just say work is going to be the magnitude of the force, the magnitude of the displacement, and cosine of the angle between. So that means the work is going to be mg times delta y times cosine of 180, or it's negative mg delta y. That means the change in potential energy is equal to positive mg delta y, because the change in potential energy due to gravity is going to be the opposite sign of the work. It's the negative of the work done by that force. In this case, we can also think about U final gravity minus U initial gravity must look something like mgy final minus mgy initial, which implies that the gravitational potential energy must be mg times the height y. Okay, I made a reference earlier to a reference point, and for gravitational potential energy, reference point is important to consider, but you can put it anywhere you want. So for gravitational potential energy, you must set y equals 0 somewhere. There aren't really particular rules. It can be anywhere. Because it can be anywhere, we usually just set it to be 0 at the lowest point. Because that's simple. You can have your axes reversed and have down be positive and up be negative. You can have up be positive and down be negative. You can put y equals 0 at the highest point. You can put y equals 0 at the lowest point. As long as you are consistent, the results will be the same. It's pretty neat. And that's it for gravitational potential energy. This was a real short one. Hope you enjoy it. Come back next for elastic potential energy, something a little harder.